Design components. Design components are a powerful feature of FramerX to turn any part of your canvas into a reusable element that propagates its changes to any copy. They allow you to create repetitive designs very efficiently. To create a design component, select any frame in your canvas and select the components. Blah, 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 Command K, yada yada. One master, many instances, blah, blah, blah. Overrides. Design components instances can have overrides where they visually differ from the master. To override any instance, double-click it and make edits like you normally would. If you now edit the master, you'll notice the overridden properties do not get updated anymore, but everything else will. Additionally, to reform overrides, you can also add managed overrides to design components to create a custom property interface in the properties panel. Ooh, how do you do that? FramerX detects any text layers and frames with an image fill in your component hierarchy and lets you define their contents as properties. This is great for when you want to create easily configurable components without editing them on the canvas. Okay, this is pretty cool. Let's create a simple card with a profile image and name and turn it into a design component. If you select the master, you will see a section row / master in the properties panel with two label fields, a text and image field. Name the text field name and the profile avatar and enable them in properties. Okay, so they made this guy. It's got an image, it's got a name. All right, image, and name. Okay. Okay, that's cool. Dude, so auto props. Neat. We gotta get some code gen in here, man. Now, every instance of the row component has two custom property fields in the properties panel that you can easily configure from the interface. Obviously, you can still directly edit them from the canvas too, and they will stay in sync. Cool. Exporting, importing from code. Every design component gets exported automatically, making it importable from code. This offers great flexibility as you can express them dynamically with loops to create dynamic lists or grids with real data. So cool. Make sure you're set up. VS Code. Let's start with the design component we created for overrides in the previous paragraph. Make sure you name the design component in the layer panel, in this case, row. As soon as you name the component, code for it gets exported in the code/canvas.ts file. From there, we can import it into any other code like import row from canvas. The imported row is a React component with the properties you defined in the master. In this case, profile and title. Using a component will look like any other component. So cool. Let's try to make a list with the row component based on an array. Start by creating a new code component from the component panel and adding the following contents. Stack, row. Oh, you can use stacks from inside the codes. Sweet. Okay. Okay, so you got a stack of rows. We are using our stack component to build a vertical list based on a loop of the names array. You can add or remove items and see the component reflect it on your canvas. A great way to dynamically build components based on visual components with real data. Very cool. In the future, you can import the design components from any React project, so you'll be able to export and use visual components from FramerX anywhere. Interesting. Store publishing. Code components. Requirements. Before blah, you need a code editor. React components. As code components are just React components, it is useful to understand the bare basics of React, but not truly needed. As React components are just use JSX and blah 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 blah. Yada, yada, yada. Creating a code component. To create a new code component, go to the Components panel, left side of the window. Click New Component, then click From Code. Pick a name, no spaces. Click Create and Edit. Edit it. Components fully behave like you would expect in the preview, but a bit different on the canvas. For example, scrolling and click handlers don't do anything on the canvas, as that would not mix well with manipulating in tools. Layout and sizing. Every component rendered on the canvas or preview is wrapped in a frame, so they have some layout rules as anything else on the canvas. Both the width and height are passed to the code component as props, so you can use them. Width and height. TypeScript type annotations are not strictly required, but it's nice. Displaying canvas elements. Because the code determines the contents of code components, you cannot directly edit code component content on the canvas. But often you'd like a code component to display something else from your canvas. For example, a card component could render an image with some overlay that is somewhere else on your canvas. You can accomplish this in two ways. Using props.children. Okay, props.children and imports from canvas. Exposing controls. So you've got your property controls, available controls. We've done through this already. Fused number, hiding controls, using the Framer library. React components can do pretty much anything, but React itself is purely focused on composing interfaces from components. To do anything else, from managing application state to drawing graphs, it's very common to leverage other libraries. The main use case of FramerX is prototyping, which typically includes flows, scrolling, animations, and gestures. FramerX includes an optional library of helpers called Framer.js for these tasks. Using these is not required. You can use anything you like, but they should make interactive prototyping more enjoyable in most cases. Using external libraries. Work in progress. Using asset from components. Work in progress. Editing components from packages. Work in progress. But you can copy the code. Store. Nothing. Code. Code in Framer. FramerX lets everyone do advanced interactive design without using a line of code, either by using the interactive tools or by using components from the store that were built by others. If you know React and are looking to build your own components, you can use code to make them do anything, just like any other component you ever wrote. FramerX uses code in a different way than you might be used to from a design tool. FramerX does not generate code for you from your designs, but instead it uses code that you wrote to compose interfaces. This is better because you can share code with production. Your design component can be the exact same version that runs on your production website, so there is a single source of truth. And auto-generated code ultimately almost never ends up in production. Developers want to have full control over every aspect and will typically always rewrite it by hand according to internal standards and processes. So there's no point to do code gen because the engineers are just going to rewrite it anyway, so what's the point? Types of code. Framer uses code in two distinct places, components and functions. Components are React components. They are part of an interface that you can compose into large applications. The code that you typically write for components concern just that component. So for a slider, it would contain the code to draw the knob and rails, plus the code to handle the scrubbing. Nothing more than that. Code overrides facilitate communication between components. To turn components into an app, they need to communicate. So the slider has to maybe change the position of something. Code overrides allow you to override any properties before the components get previewed, update or respond to application state, and attach event handlers to make things interactive. Note, Code overrides are very minimal on purpose so that you can use them any way you like and do things like bring your own state management like Redux if you want, or no state management at all. Overview. All code in Framer is expressed in plain React using JavaScript, ES6. A component can be as simple as just one HTML tag with some CSS, all the way up to very complex media player with rich interactions. This also means that people with a variety of skills can make components. If you know basic web development, you can learn to build them in 10 minutes. If you are an advanced engineer that knows React, you don't have to learn anything new. Everything will just work like you expect. Note, under the hood, FramerX actually uses TypeScript, a typed version of JavaScript. Types help to manage larger applications that help to offer really great autocomplete for editors. But TypeScript will become completely optional so that you will also be able to just write ES6 if you like. Note, although there might be a way to create React Native applications in Framer in the future, we don't offer an official way today. You are, of course, free to explore how far you can come yourself. Our open source Framer library should contain everything you need to get started. Editor setup, blah, 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 workflow. If you edit any FramerX code, it automatically gets updated in FramerX when you save the file. So components get re-rendered on the canvas and in the preview, and functions get updated under the hood. If you get an error, the component will turn red and display the error message with optional suggestions where to look for the exact error. There are two types of errors. One, a syntax error. You likely made a typo in your code, and the computer doesn't understand you. The most common ones are capitalization errors, missing brackets or commas. Ugh, code, right? Runtime error. Something went wrong while running the code. This can be really anything. Errors are listed at the bottom right of the screen. To deeper investigate errors, you can use the web inspector by clicking the error counter, or right-clicking in the preview and choosing Inspect Element. TBD. Editing components from the store. A note, we recommend using a window manager like Magnet, blah, blah, blah. Okay, packages. Packages are just zipped JavaScript packages that we manage. That's, .framerx files. You can reveal the content of the package with file show package. The package files disappear once you close a Framer project. That's a really important thing to keep in mind. So if you're editing the code and you don't hit save in FramerX after you change your code, it doesn't get saved anywhere. Or, your changes get erased. They evaporate if you don't save your FramerX file. Important to know. Next, code overrides. Code overrides allow you to change any frame or component on the canvas with code before it shows on the preview. They can, for example, change a visual property like color or opacity, add an interactive event handler with animations, communicate between multiple frames or components, or handle user input and apply real dynamic data. Code overrides are simple JavaScript functions you can write yourself and apply to any frame or component on your canvas. So they are highly shareable. The functions are simple transformers that get the properties from the canvas as inputs, props, and return them with modifications. Code overrides can live in any code file in your project. They get discovered as they use the override type specifier. Like this. Events. So you can do like on tap, animations, you can do like animatable things. Right, we went over this already before. Okay, application state. Every complex project has a set of parameters or variables. Whether the user is logged in, what a choice was on a previous screen, or a downloaded set of friend names. The displayed user interface at any point is a result of all of that data, and any change to it should update the user interface. The Framer library provides a simple data object that does exactly that. It behaves like a plain JavaScript object that you can store anything in, and it updates your project's user interface every time anything changes. A data object. Okay, let's look at two code overrides that update the text of a frame when you click another frame. Start by setting up a new document with a frame and text. So make a new document, looks like this. It's got a frame, it's got a button, it's got some text. Now let's write 2 code overrides, one for the button and one for the text. So the text changes when we click the button. Okay, so we import this stuff from Framer, we import override, and we import data. So our app is data with name Coon. I think that's how you pronounce Coon. And then, so one override is called useName. It's an override. It's named useName. There's another override. It's called useName button. And what useName does is it sets the text of this component or frame to app.name, which is app.name. And this thing, useName button, defines an onClick, which when clicked, the app.name will change to Yorn. So, let's see. I'm guessing that you click the text, apply the override to the text. Can you apply an override just to text? Or can you apply an override only to frames? Well, I guess we'll find out. The app variable holds the data object with the name set to Coon. The useName sets the text property to the value of the name. The useName button updates the name value to Yorn. As soon as it gets updated, you'll see the user interface reflect it. Okay, neat. Yeah, I gotta play with overrides some more. It seems very powerful. Next, Framer library. Some features of this page are still in development and will only become available in a later bit. FramerX provides a library with a set of optional helpers for React to create animations for high-fidelity motion design. Animations let you change any property over time on a curve like linear or spring. You can animate as many items as you like, build animation sequences, and use animation events to respond to user events. The Framer.js library will be open source, and we will strive to support most major browsers so that you can optionally use it in production environments if you like. Note, the Framer library is completely optional for your components. You are free to use any library you like, or none at all. Note, in future beta, the Framer library will have interpolation, tween between number ranges, and gestures. Advanced gestures and behaviors like swipe, pinch, etc. Cool. Animation. In FramerX, you animate values instead of objects. A value can be a number, color, or even string. If you use these values on any Framer component, like the left property of a frame, they will animate very efficiently. The programming API for Framer animations are loosely based on the standard Web Animation API. It consists of the following parts. Animatable views. Animatable values. The value that can be animated. Number, color, and string. Animation function. The animate function to create new animations for any value with options like curve and duration. Animation curves. Curves for different animations like linear, spring, or Bezier. Animation object, the actual animation that you can control with play, pause, and reverse. And animation events, things that happen to animations like start, finish, and cancel. Note, the Framer animation approach is loosely based on React Native Animated library. Usage. Let's look at the simplest example to use a Framer animation. This should look fairly familiar if you've done any web development before. So you got import frame, animatable, and animate. So we define the left as an animatable value that starts at 0. And then we set the left of this frame to this animatable left value. And then when it's clicked, when the frame is clicked, we animate the left value from whatever it currently is to 200. This builds a simple React component with just a single frame that has the left property bound to an animatable value, this.aLeft, animatable left, I guess, something I made up. The default value is 0. The onClick handler of the frame uses the animate function to animate the value to 200 with a default linear curve and duration of 1 second. In the example above, we did not set any animation options, so it uses the default ease curve. If we would like the spring curve with options, we simply use it as this, animate.spring, and then you can pass tension or whatever. There are a couple of curves available, linear ease, ease in, out, with options, duration, spring with options, tension and friction, and Bezier with, numbers, or Bezier.ease and Bezier ease out. Events. Events provide a powerful way to respond to changes in animations. This way you can build up sequences or build non-linear flows, like when a user interrupts an animation. Cool. Events in Framer use a modern JavaScript feature called async and await. They are powerful primitives, but you can simply think of them as ways to wait until something happens, like an animation ending or being interrupted. Let's look at a simple example that waits for one animation to finish and then immediately starts a new one so it ends up where it began. We'll use the async and await constructs to wait for the finished state. Okay, so we are importing blah, blah, blah. We got our example. We've got a left. We're defining an animatable value called left. And let's see. So on click, we're using an asynchronous or async function that first we await. So we wait for animate to be finished. So animate left to 200, finished, and then immediately after this happens, we animate it back to 0. Okay. So now when we click this thing, it will animate to 200 and then to 0. When using await, your function has to be marked async. This is how JavaScript works. So notice async next to the onClick function. From there, you can see we use await with .finished on the animation to wait before running the next line of code, so that the animation only starts with the previous one is done. If you were to remove the await keywords, both animations would start immediately. That's not what you want. The other available events are ready. The animation is ready to start. This happens automatically if you use the animate function. And finished. The animation finished completely. Technical information. Animations only work with Framer components, as we directly modify the DOM. Animations are technically observables, much like React Animated. Animations directly modify the DOM for performance, so they don't trigger React tree diffs. Animations in Framer are cross-browser compatible from IE8 and up. Yay. Interpolation. Nothing. Components. Nothing. Events and gestures. Nothing. Changelog. Okay, this hasn't been updated in a while. Yep. Tutorials. Nothing. And nothing. And nothing. And nothing. And nothing. Yeah, it's nothing. React component authors. That's me. I'm a React component author. How we render components on the canvas. The container frame, the width and height props. Limitations. Iframes on the canvas are blocked. Limited execution time for render methods. Other planned limitations. Sandboxing. FramerX experience for component consumers. Expose props directly on the interface with control types. Specify topics. Events. Blocked on the canvas, working in the preview. Should account for preview scale. CSS transform. styling, inline styling preferred, but everything else should work. We might limit inserting arbitrary CSS, glamour style components in the future. Media queries only work well in the preview, as the canvas lives in an entire window by itself, so queries respond to the whole window instead of the root frame artboard. Publishing existing components to the store. Anatomy of a package, zipped JS project with package.json. Add your components as a dependency. Expose components you'd like to expose. Optionally add interface, see above. ES6 versus TypeScript, blah, blah, blah. Okay. Always keep the Framer library up to date. During the FramerX beta period, you will be making tweaks continuously in order to provide you with more features and overall better experience. This can also lead to you seeing bugs in the meantime. When you see an issue appear, first check if the blue Update Library button is pressed in the bottom left of your FramerX beta app and click it. Or present. The button is present. If the issue persists, then please let us know. FAQ. Well, there will be a Windows version eventually. What kind of code does FramerX generate? The point of FramerX is not to generate code for you, but to use the code you or someone else wrote to compose interfaces. We do, however, aim to be able to let you import design components from any arbitrary React project on release. Private store, stateless components. Can I use React stateless components? You can. Well, we just use React.component in the docs, not to confuse beginners by mixing the two. If you are a beginner who is now curious, read this. How do I style React components? How do I see the package contents? How can I use an external NPM libraries? Can I use multiple canvas children for my code component? You can currently only access props.children, but we're working on better ways to mix code and canvas. Can I use FramerX projects with Git? Right now, packages are binary zipped files that not great for Git. We're looking to improve that in the future, and we think we can because Git is smart. Git is smart. What will happen to Framer Studio? I don't know, I never used it. Okay. Can I open Framer Studio.framer files? No. Can I use the Framer theme for my editor? Framer created the syntax theme, awesome looking themes for both Visual Studio Code and Atom, so that you can code your components in true Framer style. Yeah. Cool. Smiley face. Alright. What do we got? Framer library. I don't think this is the latest, is it? No. No, this is not. Okay, so what else we got? Resources. Learn FramerX in a way that works best for you. Watch guided videos, work through a course plan, or follow along with an example project. Cool. Guided courses, design plus code. Learn about layout, code components, and animation in Meng 2's 6-part video course. FramerX plus React. Dive into the fundamentals of React with a 27-lesson plan and video course by Linton Yi. Downloadable projects. Stacks. Learn how the Stacks tool makes it easy to design adjustable layouts. Linking. Discovered how to use the link tool to easily connect between screens, scrolling, and components. Learn how to create reusable design and code components. Let's check this out. Learn how to use a master component, override instances, and insert code components. Cool. All right, layout tools. Oh, we did this already. Okay, here's ooh, snazzy. Design and code in Framer X. Create powerful design and code components for your app and design system. Available now. This is from designcode.io/framer-x. Start free course. Designers can create production-ready React components. Framer X is the only design tool that allows you to create code components that can be used in a real React site. Powerful interactive design and code tools. Your components and the single source of truth. Okay, let's see what this thing is. Okay, this is learnreact.design/framerx-react. FramerX plus React. Get productive in FramerX. Learn React fundamentals. No coding experience required. Thank you for making it so easy to learn. Okay, so this is a third-party thing that costs money. Good to know. And this is a third-party thing that does not cost money. Well then. Okay. And what do we got? Alright, cool. Alright, and see you later.